Okay, for topic 4, we're going to discuss radians. And a couple of videos ago, we were talking about measuring angles. And I told you at that point we could measure angles in degrees or radians. In that video, we focused on degrees. We now need to introduce this idea of radians. So, in short, like the most barest definition of radians is it's a way to measure angles. So, this is a way to measure angles. But we have to understand what a radian is. So we have kind of a wordy definition here we're going to look at first. So for the definition, we have a radian, denoted by theta, is the measure of the ratio of the length of the arc, which is just part of the circle's circumference. It spans on the circle. So let me read that again. A radian, denoted by theta, is the measure of the ratio of the length of the arc it spans on a circle to the length of the radius. Okay, so if we're talking about theta and we're dealing with radians, we're very specifically looking at a ratio, which is going to look at the length of the arc, and it's going to compare it to the radius. Okay, so when you're dealing with a circle, okay, let's say we have the radius and then we have some arc. This, oh goodness, my setup just about fell. This right here is an arc. It's just part of the circumference of a circle. Okay, so that's what we mean by the length of an arc. Okay, now we need to get a little bit deeper into that. Okay, so we know that we can look at this ratio of the length of the arc to the radius, but we need to know what is 1 radian. So essentially, 1 radian is the central angle. Sorry. 1 radian is the central angle needed on any circle. Doesn't matter the size of the circle. It's the central angle needed to make the arc length equal to the radius. Okay. So we have an image down here. Okay. So we have a circle. We can see that. We have a vertex. We have a radius. So that's going to be this right here. Now imagine that radius. Imagine we cut a string that was exactly the length of the radius, and then we just laid it around the edge of the circle, and we created an arc, okay? So we have this radius right here, and this arc length, we're told, is exactly the same length as the radius. Well, the angle that creates that situation is exactly 1 radian. So 1 radian is the angle needed to form an arc that is the same length as the radius. So that is 1 radian. So 1 radian is the angle that creates an arc length that is exactly equal to the radius. Okay. So kind of like breaking this down, we have initially that a radian is the angle that measures the ratio of the arc length to the radius. So we have this ratio arc length compared to the radius. Well, let's go ahead and say that we're going to call the arc length S. So we're over here. And we're going to call the radius r. So essentially we're saying, okay, we have that theta is the ratio of s compared to r. Well, we know that we get exactly 1 radian when the arc length s is exactly equal to r. And that kind of makes sense because we know like when we're just dividing fractions, if we have some number and we divide it by exactly itself, we just get 1. So when the arc length is exactly equal to the radius, we get 1 radian. Okay? Now that leads us to something called the arc length theorem, okay? So we have a way now, whether you see it or not right now, we have a way to find a measure of the length of an arc, okay? So that's what the arc length theorem is. It says that for a circle of radius r, a central angle of theta radians subtends an arc whose length is s equals r theta. Very wordy, very formal, but let's really break that down. We're saying that we can find the length of an arc using this ratio right here. Okay, so we already know that theta is the ratio of the arc length to the radius. Well, if I wanted to figure out what the arc length is, I could just solve this formula for s. And in order to do that, I would just multiply both sides by r. Well, on the right, r's just become 1. R divided by r is 1. 1 times s is s. So we get s equals the radius times theta. And this is our arc length formula. So this right here. Now, understanding where it came from is important, but right now we just need to know what it is so that we can use it, okay? Now, I did mention a couple of things here, so let's go ahead and talk about that. In the definition for the arc length theorem, or in that theorem, we use the word subtends. Subtended just means an arc that is cut by two radii. So like when you create an arc with a radius and then a radius, it's just subtended, okay? That's just a fancy word. And then this theorem only works when we're dealing with radians because of this right here. This right here, this ratio is a radian equals arc length divided by radius. 1 radian is specifically when the arc length is exactly the radius. So this only works for radians. Only works for rad. I'm just going to put rad. Know that that means radians. Okay. So only works for radians. Okay. Now let's use that formula. Example 7, it says include units with final answers. Okay, solve and include units. So part A, it says find the length of an arc of a circle with a radius of 10 meters subtended by a central angle of 0.5 radians. Okay, so we have a circle. Okay, we have a radius of 10 meters. Okay, we know that we have an angle here. Theta is 0.5 radians. So what we want to know is what is this arc length? Okay, so we know that arc length is the radius times theta as long as theta is in radians. Okay, so let's fill in what we know. We know that the radius is 10 and we know that theta is 0.5. So S equals 10 times 0.5, or, well, 10 times 0.5 is just 5. So we get 5 meters. So this arc length right here is 5 meters. Okay, so it's that simple. It's just a formula that we can use. Okay, now part B, it says you walk 5 miles around a circular lake. So there's some circular lake. Let's say it's got a little path around it. Give an angle in radians, which represents your final position relative to your starting point if the radius of the lake is 2 miles. Very wordy, but this is all it means. Kind of draw your circle. That's our lake. Okay, we could put ducks in there if we wanted to, but we don't have time. Now, we're told that the radius of this lake is 2 miles. Okay? What we want to do is we want to figure out what angle would create the 5-mile arc that we just walked. So let's say we walk 5 miles. So this is where we end up. Okay? We want to know what angle creates that. So let me move my 2 miles just so we can see what's happening inside here a little bit better. We're going to say 2 miles. We want to know what this angle theta is. Okay, so we know that arc length is S equals R theta. Well, what do we have? We know we walked an arc around this lake of 5 miles. We also know that the radius is 2 miles. What we don't know is theta. So all we have to do is kind of treat theta like it's a variable, solve this for theta, and we'll know what theta is in radians. So to get theta alone, I would need to divide both sides by 2. 2 divided by 2 is 1. 1 times theta is just theta. So theta is 5/2 radians, or 2.5 radians. So the angle that created that 5-mile arc that we just walked is 2.5 radians. Okay, so that is how you use the arc length theorem. Okay, so understand what a radian is. It takes a little bit to wrap your head around it, but this visual right here is really, really helpful. Understand how that leads us to this arc length theorem, and then know how to use the arc length formula. Okay.